Well, good morning, everyone. My name's Chris Harrop. I'm a member of WPD's innovation team, and it's a pleasure to welcome you to our first WPD Innovation Showcase event. Today, we're building on the previous series of WPD Balancing Act events, where we've presented progress and findings from a wide range of projects over the years. We're delighted to be presenting progress on 8 projects today that we've got ongoing at the moment, and these are on topics that you've asked us to cover. Plus, we'll be running a breakout session where you'll have the opportunity to discuss and ask questions on material that you do hear about today. So the format of the event on this occasion is quite different for obvious reasons, and we hope that you've got somewhere comfortable to be viewing this from. Throughout today's events, as well as presentations, we'll run a number of poll questions, and we're going to start with that right now. So here's our first one. What we'd like to know is a little bit about you and specifically the organisation that you currently work with. So let's get that first poll question running. Okay, so that should be running now. So we'd very much like it if you could. Oh, lovely! Thank you very much indeed, folks. So as I say, the question is simply, you know, where have we got folks attending from today? And we're just going to allow a few more seconds for responses to come in. Okay, lovely. All right. Well, a fair mix of people that we've got today, which is absolutely great. Shaded consultancy versus DNOs, but manufacturers and colleagues from academia and everyone from elsewhere as well. Thank you for that, and thank you for joining us this morning. Now, before we start proper, could I just ask you to do one piece of admin for us? Could you just make sure that your name, which you'll see in the participants list from Zoom, is correct and complete, and that it also includes your company, if you could. To do this, all you have to do is hover over your name in the participants list, click on the 3 dots or more button, and rename is an option there. So if you could do that over the next few minutes, that would be great. Okay, well, thank you for that. I'm now very pleased to introduce Yango Mavrokostanti, who's WPD's Innovation Team Manager, and she's going to properly introduce the innovation team and this showcase event. With no further ado, Yango.
Thank you, Chris, and welcome everyone again to our event. My name is Yango, and I'm the Innovation Manager at Western Power Distribution. Through today's event, we want to share with you our learning from the innovation work we are currently doing, and we'll be covering the topics you told us you're most interested in. We hope to inspire new ideas, have some great conversations with you in our workshops, and as we're always looking for new people and organizations that share the same values with us, we want to encourage you to get in touch if your ideas can help us transform our network. I'll start by explaining who we are and what we do as a distribution network operator. I'll then discuss the need for innovation and how that links to our changing role. I'll present our values and commitments and explain how they shape our innovation strategy and priority areas, and discuss how we innovate to deliver our current portfolio of projects. In the end, I'll talk about our call for ideas and how you could get involved. As a distribution network operator, we are responsible for maintaining and operating the electricity distribution network in the areas that we cover. Our license areas include the East and West Midlands, South Wales and South West England. We are responsible for distributing power to our 7.9 million customers. Our traditional role as a distribution network operator involves maintaining our assets, our transformers, underground cables, and overhead lines. It also involves connecting new customers and responding to faults. Our network, however, is changing, and therefore our role also needs to change. We now have an increased number of low-carbon technologies connected to the network, including renewable generation, electric cars, and the energy storage, and we expect this to grow even further in the future. This is introducing complexities in the way that power flows in the network. We need to respond to these complexities and find new ways to manage the network. We therefore need to transition to a distribution system operator, and as part of that, we need to design, create, and trial new technologies that will enable our network to become intelligent and make the most of its existing capacity. We need to continue creating new commercial arrangements with customers so that they can help us manage the network in real time by changing how much they use or generate through the provision of flexibility services. And we need to do all that while at the same time ensuring that electricity remains affordable for everyone. And that's exactly why we need to innovate. We need innovation in order to be able to create all of these new solutions and systems while at the same time keeping electricity affordable for everyone. Our innovation strategy is what shapes how we innovate at Western Power Distribution. Everything we do evolves around our values of decarbonization, excellence, and value for money. We want to be a main contributor to decarbonization, and we want to do that through our innovation work. We want to be working with the best people to achieve excellence together through our innovation projects, and we are passionate about providing value for money to our customers and using our innovation funding the best way possible. The team consists of a number of engineers who are dedicated to implementing our innovation strategy. What we do is that we identify problems, find solutions, and trial them through our innovation projects. Our innovation strategy is based around our commitments. We recognize that as a distribution network operator, our role is very important in facilitating the energy transition. We are committed to overcoming the barriers to the transition to a low-carbon future and ensuring that our network will be able to facilitate it. We will continue to efficiently and effectively transform our network through our innovation work. And in order to make the most out of our existing network, we will continue to develop new technologies, commercial solutions, and standards. This will ensure that the energy transition takes place in a way that keeps the electricity affordable for everyone. At the same time, we are committed to working with our communities to understand how we can support our vulnerable customers and ensure that they benefit from the opportunities that will be created through the energy transition and that no one will be disadvantaged. In order to meet our commitments, we recognize that we need to be focusing on the right areas. In our innovation strategy, we have set out the priority areas that will shape the types of projects that we do. Decarbonization and net zero, heat, transport, communities and consumer vulnerability, and data are our main priority areas, and our projects are focusing around these topics. So that shows how the priority areas we have defined in our innovation strategy determine the types of challenges that our projects need to be addressing. In terms of how we innovate, the first step in the process is to generate the ideas and create the new projects. As part of that, we run external calls for ideas, where we ask everyone to submit to us their ideas for projects that might benefit our network and our customers. These are usually themed around a specific priority area from our strategy. A number of our projects are generated from within our business. So we involve our experts in these discussions in order to understand better what types of challenges they want us to be addressing through innovation. We also collaborate with other industry institutions in the process of creating new ideas. After the ideas have been generated, we assess them based on the level of risk and benefits, and also to determine whether they align with Ofgem's governance and funding criteria. That's because most of our projects are funded through Ofgem's funding streams. Our projects could be funded either through the Network Innovation Allowance or the Network Innovation Competition. The Network Innovation Allowance provides us a specific amount of money that we can use every year for smaller scale innovation projects. These are usually research projects or projects covering a feasibility study or even a smaller scale trial. The Network Innovation Competition provides us an opportunity to go into competition every year with all of the other networks and gain funding for larger scale innovation projects. These are usually projects that involve the creation and design of a new system or solution, and its large-scale trial in the electricity network. We are always looking for new ideas for great projects that can benefit us and our customers. So if you do have any ideas, please feel free to get in touch. This provides a snapshot of our current innovation program and shows all of the Network Innovation Allowance and Network Innovation Competition projects that we are currently running. We'll go into more detail on some of these projects in the sessions later on, and you'll also be able to ask any questions you might have in the workshops later on in the day. In case you are not aware, we are currently running a call for innovation ideas for projects that we can take through to the 2021 Network Innovation Competition. Our call for ideas will be open until the 8th of December, so we welcome you to submit your ideas. If you have any questions, please feel free to get in touch with us. So in this overview, we've covered who we are and what we do as a distribution network operator, and how our role is changing as we transition to a distribution system operator. We've seen the challenges that we are facing due to the high number of low-carbon technologies connected to our network, and how innovation will be very important in ensuring that the future electricity network can facilitate the low-carbon transition. It's innovation that will give us the new solutions and skills and knowledge that we need in order to make our network intelligent and sustainable while keeping electricity affordable for everyone. We've seen how we innovate at Western Power Distribution and our values of decarbonization, excellence, and value for money that shape our innovation strategy. We've seen the priority areas that determine the challenges that our innovation projects need to be addressing so that we can transform our electricity network. Decarbonization and achieving net zero is one of them. Supporting the electrification of heat and transport, using our data the best way possible in order to drive value for our business and our customers, and also supporting our communities and vulnerable customers through the energy transition. We've seen the sources of funding that we use and how we create and generate new projects. We've also discussed our current call for ideas, where we welcome submissions for innovation ideas that we can take through to the 2021 Network Innovation Competition. In the following sessions of this event, you'll be able to hear more about the great work that we are doing in our current projects, including designing and trialing new ways of providing vehicle charging solutions at service stations, finding new ways to monitor our network so that we can get the information and visibility that we need in order to make it truly intelligent, and also how we can use our existing assets in order to improve power quality. I hope you enjoy the following sessions of the event, and thank you again for joining us today.
Thank you, Yango. So that brings us to our first project presentation today, which is looking at primary system power quality and specifically how we can better understand more of what's going on. So Steve.
Hello, my name is Stephen Pinkerton Clark and I am an Innovation and Low Carbon Network Engineer for Western Power Distribution. Today we're here to talk about the Primary Networks Power Quality Analysis project. So Primary Networks Power Quality Analysis, otherwise known as PNPQA. Today's presentation will talk about the project overview, the problems the project is trying to solve, the progress and key learning, and what happens next. PNPQA project overview. The main project partner with this project is Nortec Management Limited. It is a Network Innovation Allowance project with a total of 1.35 million and a duration of 3 years, running from March 2018 to March 2021. So this project aims to reduce uncertainties around power quality within primary networks and facilitate increased integration levels of low carbon technologies, LCTs. This will be achieved through implementing a monitoring and analysis system for assessing the PQ and harmonic content of waveforms in primary networks, verifying the accuracy of the primary network equipment used for PQ monitoring, and using modelling to predict the future PQ impacts of increased integration of LCTs. The project is split into 4 phases. These are a design, build, trial and report. So in the design, this first phase of the project includes testing the harmonic performance of voltage transformers, selection of trial areas and sites, specifying PQ monitor interfaces and PQ analysis software. The build stage is the second phase of the project, and this includes developing interfaces to enable remote communications from PQ monitors, purchasing and installing the PQ monitors, developing software to automate the retrieval and analysis of PQ monitor data, and building power system and LCT models for future-looking PQ studies. The trial period is the current phase, and this combines a wide-scale trial of communicating power quality monitors with software to automate the collection and analysis of PQ data, along with modelling and analysis to understand the future impact of increased LCTs on primary networks. Additionally, this phase also includes follow-up VT, voltage transformer harmonic testing. What are the problems that this project is trying to overcome? The impact of power electronic devices on the harmonics and power quality of primary networks is currently uncertain, as more and more low carbon technologies are connected with power electronic inverters. The effects on the network moving forwards are increasingly unclear. The harmonic content of waveforms and power quality, such as flicker, voltage sags, and swells, voltage unbalance, within the primary network is not routinely monitored at present. However, WPD is now required to publish harmonic data in order to facilitate LCT connections. Existing business practices use snapshots of PQ data for analysis. For example, a week of data is used to represent the entire year of network operation. The major drawback with this approach is that the data captured during the short monitoring period may not be truly representative of the worst-case network operating conditions seen during other times of the year. In addition, current business practices are labour-intensive in terms of retrieving data from sites and analysing the data. Moreover, current techniques do not give WPD full visibility of power quality harmonics away from the LCT points of connection. So primary networks power quality analysis progress. The project is currently in the third phase, which is the trial phase. Power quality data is being received from all 46 communicating power quality monitors that have been installed on the West Midlands licensed area. The software to automate the retrieval and analysis of the power quality data has been completed. Analysis of the first 6 months of monitoring data from all sites is underway. The power system models for future-looking power system studies of the potential power quality impacts of increased low-carbon technologies have been enhanced to increase modelling fidelity, and initial power system studies are underway. And follow-up voltage transformer testing at the National Physical Laboratory has been kicked off. This is to validate and extend the earlier testing done by the University of Manchester, and this should be finished in early 2021. So the key learning for this project: due to the COVID-19 pandemic and the lockdown from the start of March, National Grid has reported that demand fell by up to 20%. So changes in the power quality due to the COVID-19 pandemic response were very clear. It is clear to see that there is a significant up to 40% and sharp drop in power to demand during March, followed by a slow rise up to September, with an obvious lessening of the differentiation between weekday and weekend demand. Coincidence with the decrease in demand has been an increase in voltage total harmonic distortion. There is a sudden rise in THD at the start of lockdown, which is maintained until June. The analysis of data collected so far in 2020 has revealed some changes in the power quality due to the COVID-19 pandemic response. As stated previously, National Grid has reported that demand fell by up to 20% during lockdown, and changes of that magnitude have been seen at some of the project's trial sites. For example, the graph shows the mean daily real power measured at the two trial sites, Method C 33 kV BSP and Sherrington 33 kV primary, which is fed by Ryford BSP. Relative to the mean real power for January and February, it is clear to see that there is a significant up to 40% and sharp drop in power. So this is demand during March, followed by a slow rise up to October. At the start of the lockdown period, there is also a lessening of the differentiation between weekday and weekend demand. So the weekend demand is typically lower as energy usage behaviour changes. For Method C BSP, total harmonic distortion rises steadily throughout March and is sustained at elevated levels until September, when there is a noticeable decrease. At Sherrington, there is a sudden rise in total harmonic distortion at the start of lockdown, which is maintained until June, when maintenance activities result in the significant changes to THD seen in the graph. The change in demand and coincident changes in power quality due to the COVID-19 response may result in the majority of the data collected in 2020 being unrepresentative of usual operating conditions, and therefore may be unsuitable for the future-looking power system studies. That risk is being monitored. This activity will continue into the next reporting period. What are the next steps for primary networks power quality analysis? So the PQ monitor trial will continue into the start of the next reporting period. Analysis tools will continue to be developed and will be applied to the first 6 months of data to produce an interim data analysis report, and then to a whole year of data to produce the final data analysis report. The modelling and studies aspect of PMPQA will continue, with studies using existing PQ data and data from the PQ monitor trials taking place and being completed. A report analysing the findings from the studies will be produced. And the follow-up VT testing done at the National Physical Laboratory will continue and should be completed. I'd like to thank you all for listening to the project overview of PMPQA today. If you do have any questions, please feel free to get in touch with my email address as below, or at wpdinnovation@westernpower.co.uk. Thank you.
Thank you, Steve. It's great to hear of the progress being made in developing future business as usual methods for more widespread monitoring of power quality. Now, before we move on to the next presentation, I just wanted to say that you'll get the chance to ask questions during the breakout session that will start around 12 o'clock. So hold on to those thoughts and questions. Our next presentation is looking at the combined impact that we might have from a number of low carbon technologies that may be found together in homes of the not too distant future. So Matt.
Hi, I'm Matt Watson from the innovation team at Western Power Distribution, and I'm here today to talk to you about our multi-asset demand execution project, generally known as MADE. I'm going to start by doing a quick overview of the project, then talk about the progress we've done today, discuss the key project learnings, and then discuss the next steps beyond the project. MADE is a £1.6 million network innovation allowance project. It was delivered by Passive Systems, who were supported by Everose, Imperial College London and Delta E, and it ran from March 2019 and is closing down this month in December 2020. The initial focus of the work was to try and build on existing trials that had looked at single low carbon technologies and try and understand how they work when they're all in the same home. And that was, so the initial work was on modelling, and then we then built out to a 5-home technology trial, which was used to see whether it could actually be done and then to validate the model learning. So what's the problem we're trying to solve? Effectively, what Made is trying to do is to build on the learning from existing trials where we've developed understanding of how individual low carbon technologies might operate within a home, and to try and understand how different it is when you put multiple low carbon technologies within that home and create a single overarching control strategy for them. So effectively, we've got great learning about how electric vehicles could work through our Electric Nation project. We've done some good work on hybrid heating systems through the Freedom project, and we did some work on battery storage and PV generation in our Solar Bristol project. And they've provided significant learning that have impacted the way we understand these LCTs and manage our network. However, as we move to net zero, we expect that actually some homes will have multiple low carbon technologies, and actually what we want to understand is how do they interact, and can you gain more flexibility from them if you put a single overarching control system over the top of them so that they can coordinate, and effectively do you get more than the sum of the parts. As I mentioned earlier, we're very much reaching the end of the project, and so in terms of progress that we've made, is quite significant. So the project started through doing extensive modelling of data from existing trials, trying to pull that together to try and understand the sort of base value case for coordinated control. And that was done through analysis with passive systems. We also did some sort of analysis on the value to the individual that was done by Everose, the value to the whole system that was done by Imperial College, and then also some work on business models and customer appetite for some of this control through work with Delta E. And effectively all this put us in a good position to kind of show there was value to the concept, and therefore we then moved forward to a 5-home technology trial that we ran from effectively over the winter of 2019 and into 2020. That was extended slightly due to COVID. Effectively, at certain key times, we had some drop-off in electric vehicle mileage, unsurprisingly, and therefore we kind of extended a little bit into October to try and capture as much time as possible. But effectively in that we were looking at, can the control work, and then trying to understand the level, the types of interventions you can have, and to see the amount of flexibility you can. And I'm going to come on to this later, but actually, it are not quite significant levels of flexibility, some really good levels of control. Off the back of that, we then reran some of the analysis, trying to build from the trial learning. So it was only a 5-home demonstration, so we don't expect it to be sort of statistically robust, but the view was to try and basically make sure that the models sort of aligned and that you could use the trial learning to validate what we did. And then following all that, we compiled all that learning into a final report, which has now been published, and we also recently held a webinar. The project is drawing to an end, and we've developed some really good learning through it. I would point out this is a very high-level piece, and if you do want more detail, please do look at the final report and the detailed sub-reports that the project partners have created. They're all on our website. So in terms of the key learning that I see, I think the first is that you can control multiple low carbon technologies quite effectively. You can maintain customer requirements such as comfort and mileage in the EV whilst reducing their peak demand and deriving direct benefit for them. There's tangible benefit that you can see through operating in coordinated mode rather than in silos. And again, it's not that surprising considering that, you can then use things like your battery, which may only have been installed originally to try and minimize export to the grid. That can then be used to, say, help manage peak loading. And so there's some real kind of clever interactions between assets that take place. The second piece to pick out is that the controls that are put in place are very responsive to the commercial environment they sit in, and so they respond very well to time of use tariffs, very well to direct interventions that we might take as a DNO, so along related to things like our flexible power services, and they can do that whilst maintaining customer comfort. I think the interesting bit that comes off this is just the variability of what you see. Unsurprisingly, the systems follow the money, and therefore you get different profiles out depending on the different commercial environment in which they sit. So it's a really important and interesting thing to consider as we move forward with more active networks and more of these control systems. The value itself to the individuals can be quite large. So the modelling from Everett showed it can be up to £260 per annum. Now this is very much the sort of higher end of the estimate, but it is quite significant. It is also have a quite variable, so it depends on the amount of energy you use. So if you have high mileage or harder, it also depends on where you are geographically. So if you happen to be in an area with constraints and a relatively high value constraint management zone, then that adds quite significantly to that value. However, if you're in an area with no constraints, then obviously you can't access that value. The final thing to mention is that there is quite significant whole system benefit to coordinating assets. Inherently, you gain more flexibility when they're coordinated than when they work in isolation, and that has knock-on benefits to the whole system. And these are from the modelling from Imperial, these are in the order of billions per year. Now, it's important to kind of understand the context around these numbers and understand them very much as kind of the sort of value to GB PLC. So a lot of these aren't direct revenue streams that participants can tap into, but there are significant benefits for us as the country if we can get more flexibility, because you can do things like avoiding the required investment in various different various amounts of generation. So you can have the project itself is drawing to a close, but there is definitely scope for some follow-up work, and so we just wanted to highlight some of the things that could come off the back of this. The first of that would be to do a larger scale trial. So we acknowledge that there could be value in a larger trial with larger sample sets and more diverse sample sets across a more disparate geography and different sets of building types, etc. So that's one thing where you could provide additional value. We equally think that there's value in trying to understand the proposition to customers in more detail, and primarily around how accessible it is. So potentially tying it into some of the work we've done with Smart and Fair to try and understand whether this proposition is accessible and how we ensure that to make it as accessible as possible so we don't leave customers behind. I think there's further work that could be done on forecasting tools in terms of kind of LCT usage. So again, we showed that assets are highly dependent on the commercial frameworks that they sit in, and I think understanding that in more detail and feeding that into how we forecast profiles is something that's going to become more important as you get more and more control systems that can follow signals. I think we also, as I say, kind of tied to that, need to improve our understanding of the LCTs that are connected to our network. And I think it's not just about understanding where they are physically, but also understanding what control systems they have, what commercials they sort of sit under, because as we mentioned, it does massively change how they operate. And then I think the final thing is to review the process for connecting multiple low carbon technologies, acknowledging that if you have got control systems that can limit output, then you might want to consider that as part of your connection process. That's my very quick overview of the MADE project. Thanks for listening, and if you do have any questions, then please do get in contact.
Thank you, Matt. Some positive learning, I think, there coming out about the feasibility and potential benefit of multiple domestic low carbon technologies. That now brings us to the point where we're going to ask our second question. So what we'd like to do is hear about your preference of platform to hear about information on innovation projects and activities. So let me start that poll. Okay, so hopefully you should see a number of options there. Thank you, folks. Oh, that's great. Good start. So we've offered some thoughts around the website, LinkedIn, Twitter, and an innovation team email. So I'm just going to allow a few more seconds there. For those results to come in. Superb. Thank you, folks. Right, so a quick look at that. Well, there's a good deal of interest in the WPD website, which is great. Perhaps less so on Twitter, but the other thing that comes across is actually a diversity of mediums is probably something that is going down reasonably well. Great stuff. Thank you, folks, for that insight. We appreciate that. Okay, we're now going to return to the matter of power quality and harmonics in particular. Now, this project is an example of innovation that's generating learning through university research work. Now, this also happens to be one of my projects, so let's dive in.
Okay, this presentation provides a brief overview of WPD's harmonic mitigation project. I'll start the presentation with an introduction to the project, and then we'll follow progress through work packages 1 and 2 that are already complete. From there, we'll look into the future work and what's covered in packages 3 and 4. Harmonics are a concern across the UK electricity networks and result from non-linear equipment such as switch mode power supplies that are increasingly being used. The growth of harmonics from equipment on existing connections may at some stage in the future require action. One way that this might be done is to use the capability of inverters that are already connected to our network. So to illustrate this, we already have a significant number of inverters connected to our network. Their primary role is to convert renewable energy to electricity, and at times they're fully utilised doing this. However, these inverters are not always fully utilised, and during these periods they potentially have the technical capability to beneficially respond to network harmonics, so operating as active filters. So the project is investigating how an existing inverter associated with, say, a PV farm might operate as an active filter and mitigate harmonics on the network and improve power quality. On any one inverter, this would only be done when capacity existed. Partners for this work are Swansea University and Power Systems Consulting, and the work is funded through the Network Innovation Allowance. The project has been structured as 4 work packages, so we'll start with work package 1. Work package 1 was really all about preparation for the investigation work. A literature review was undertaken, identifying some of the nuts and bolts of how a harmonic mitigation control algorithm could work. So this, together with Swansea University's existing experience, provided a knowledge foundation for the work. In addition, this phase of work also created a model, illustrated here, of part of WPD's 33 kV network. The purpose of this was to allow the modelled inverters, enabled with harmonic mitigation as an additional service, to be developed and tested, and for the impact on a real network to be explored through modelling. This new model was initially tested to confirm a realistic frequency response by comparing it to an existing WPD model, and it was then tested to confirm that modelled dynamic harmonic behaviours sufficiently represented harmonic measurements taken specifically for the project. Work package 2 has been all about the development and testing of an algorithm. This slide provides a high-level overview of how that works. In this instance, the algorithm samples current from the 33 kV feeder downstream of the inverter, effectively measuring cumulative downstream load on the feeder. From this measurement, the harmonic content is established. This harmonic content is compared to the harmonic set points, and a harmonic controller generates control signals based on the difference between the actual harmonics and the desired set point values. These mitigation control signals are fed into the inverter controller with the conventional fundamental power control signals. As a result, the inverter carries out its normal power conversion function and has an additional harmonic mitigation output. This causes a cancellation of harmonic currents at the current measurement point and leads to reduced harmonic distortion in the upstream network. So let's walk through some of the key outcomes from Work Package 2. This was split into two parts: the results from testing the basic operation of the algorithm, and an evaluation of the impact of the algorithm operating over a simulated 3-week period of network activity. The algorithm was iteratively developed and tested to confirm the extent to which the 4 targeted harmonic orders could be mitigated. Without any active filter capability, the block diagram for controlling a conventional power inverter might look something like this. And if we were to measure feeder current and analyse harmonics, we'd see a chart looking something like this. The harmonics are due to loads on the network. We can clearly see 5th, 7th, 11th and 13th harmonic components. From this development work, a controller structure and associated algorithms have been developed that act on these particular harmonics. This has been designed such that the intended mitigation increases according to network harmonics and acts based on inverter available capacity. As a result, testing has shown that the upstream feeder current harmonics are virtually eliminated when the harmonic controller is switched on and sufficient inverter capacity exists. Analysis of the feeder current shows the 5th, 7th, 11th and 13th order harmonics are all but absent when the controller is in operation. From testing, we also demonstrated that harmonic mitigation is limited during periods of higher fundamental power conversion. So the next key question was, what impact does the controller have over a longer time period where the inverter's capacity to act on harmonics varies? The easiest way to see the impact of the mitigation controller is to look at traces of inverter current over the 3-week period. If we start by looking at the inverter's operation without harmonic mitigation, from the yellow trace of the inverter current, we see significant variations between days. Looking at day 2, we see it was sunny throughout most of the day, whereas day 1 saw less intense sun and for a shorter period. Perhaps the less said about days 11 and 12, the better. They were clearly very dull days. If we now look at the same measurement, inverter current, but with the harmonic mitigation active, we see a considerably busier picture. We can see that the inverter is now active outside daytime periods. We also see that the controller is more active during some daytime periods when there is little sunlight. If we also look at the maximum inverter current, marked with the dashed lines, we see that current with harmonic mitigation is no higher than current without mitigation. So let's set about quantifying the impact of the harmonic controller. So if we look at some analysis of feeder current over the 3-week period, we see a range of harmonic current magnitudes. For the 5th order harmonic shown in this chart, we see that the most frequent magnitude was around 1.3 amps and the maximum current was around 5.8 amps. But with the harmonic controller enabled, we see a very different picture from the 3-week period. Here we see that the most frequent magnitude has reduced from approximately 1.3 amps to around 0.1 amp. Without mitigation, the peak 5th harmonic current was around 5.8 amps, and with mitigation, there are very few instances of current above 0.5 amps. A small number of higher current magnitudes that do exist occur during periods when the inverter is using all its capacity to convert renewable power, so can't act on harmonics. Very similar results are achieved for the 7th, 11th and 13th harmonics. Our assessment of the controller's impact over a 3-week period was that there was more than an 80% reduction in upstream current harmonics and a 16% reduction in voltage harmonics at the upstream busbar. With more inverters operating with this type of controller, we believe that this impact will be greater, but that is the subject of the next work package. So that brings us more or less up to date with progress on the project. The next stage of work will focus on further development of the algorithm and investigate and develop the capability to implement simultaneous control action at 3 separate sites across our studied network. This will initially be seen as independent operation of the controllers. Work will then go on to develop a means of coordinating the controllers to optimise overall benefit. The final stage of the project will then seek to demonstrate real operation of the algorithm in a physical inverter within a university laboratory setting. So that concludes this presentation. Thank you for your interest in the project. If you have any questions, please feel free to contact me using the email shown.
So there we go. I think this project is a great example of the industry getting targeted research work from the university sector. My thanks to all at Swansea University. Now, moving on to our next project, we're going to have a look at the issue of data sharing and work that we're doing to establish how we can support this. So, Sam.
Hello, my name is Sam Rossi Ashton. I'm an Innovation and Low Carbon Networks Engineer for Western Power Distribution. Today I'm going to be discussing the presumed open data, known affectionately as POD. This slide serves to summarise what I'm going to cover throughout the presentation. Firstly, the project overview, then its scope, and then a little bit about what presumed open data is and means, and then the benefits of open data, openness classifications, the methodology the project follows, the triage process that the project has created, other learning captured so far, the next steps, and how you can get involved. So, by way of an overview, the funding for the project is provided by Ofgem's Network Innovation Allowance mechanism. The period is about a year from 2020, and so we're approaching the end. The budget is £580,000, and the project partners alongside Western Power Distribution are the Energy Systems Catapult and the Centre for Sustainable Energy. The scope of the project is to deliver against the recommendations made by the Energy Data Task Force in its Strategy for a Modern Digitalised Energy System report. 2 of the recommendations within the report were particularly relevant to network operators, and so we structured the project around them. The first of which was maximising the value of data. This is maximising the value to the extent that data should be presumed open, and that means discoverable, searchable, understandable, with common structures, interfaces and standards. The second recommendation that the project looks to deliver against is the visibility of data. This recommendation suggests that a data catalogue is established to provide visibility through standard metadata for energy system datasets. Presumed open is the principle that data should be as open as possible. To realise this, all data is first considered open and then challenged as to why it should not be. This represents a substantial shift from the existing way this is viewed, where data at the moment is considered closed or unavailable until this is challenged by a third party that wants to use it. Presumed open data does not, however, mean that all data will be shared. It's more of an impartial way to view data access. Data will only be shared if all issues such as privacy, security, negative consumer impact or commercial can be mitigated. As well as looking at data treatment, the project actually looked to define data use cases as well, and so to some extent the benefits of open data are yet to be fully known. Having said that, some of the benefits we can expect from opening up data are the optimised and increased deployment of low carbon technologies, meaning the reduction in customer bills and faster decarbonisation, the optimised procurement of network assets by the network operator, reducing costs, and the better identification of new energy system revenue opportunities for third parties, as well as increased opportunities to participate in existing flexibility services. In order to simplify data access, the Energy Data Task Force report proposed 4 data openness classifications. The project made the decision to use these for WPD data. The 4 classifications are as follows. Open data. This is data that's made available for all to use, modify or distribute with no restriction. Public data. Data that is made publicly available but with some terms or restrictions on its usage. Shared data that's made available to a limited group of participants, possibly with restrictions as well. And then closed data, which only remains available for the organisation that created or owns it. In practice, the public and shared openness classifications are complex and could potentially require an additional degree of granularity to ensure this data is treated correctly. To deliver against the recommendations made by the Energy Data Task Force and provide some good learning in regards to presumed open data, the project was structured into 5 work packages. The first work package, dubbed Data Discovery, served to identify all data created or held by WPD that may be relevant to third parties and documenting it into a catalogue. The second work package was Use Case Discovery and Development. This consisted of 4 workshops that were used to document and develop use cases to understand which data sets are most valuable to stakeholders. After the workshops, analysis was performed to identify this. Work Package 3 was to develop a data sharing assessment tool that would be able to triage all data into the 4 openness classifications I mentioned previously. Work Packages 4 and 5 consist of the development of an open data hub and the hosting of a data science challenge, but they are to come. This slide provides a visual representation of the triage process that's taken in order to understand the openness classification of any one dataset. The process is left to right with the classifications on the far left. First, the issues on the second row are considered and mitigation steps that would be taken. After taking them, you'd revisit the start of the process. If anything remains, then the degree that terms and conditions, limitations or group restrictions would be required to prevent these issues, then define the classification. To date, the project has completed 3 work packages. In Work Package 1, we created a data catalogue containing information on more than 100 WPD datasets. The fields of the data catalogue were chosen from Dublin Core metadata. The Energy Data Task Force recommended we use this to meet the requirements for standardisation. The key learning from this was that WPD holds a lot of datasets that stakeholders may find useful, but at the time we weren't sure how useful, and there was no repository with this information. Within Work Package 2, we held 4 use case development workshops with a variety of industry stakeholders and then analysed the output. These highlighted that there was enormous interest in the intended extended use of WPD data, and some datasets clearly had more value than others. To the left of the slide, you can see an example of how we took use case ideas and developed them into full data uses. There were approximately 140 data use case ideas developed, the analysis of which provided really useful and valuable learning, as it gives us key insight and direction for future data activity. The use cases were first mapped to 14 themes, and approximately 42% of the use cases fell into 3 key themes, which were connections, capacity and constraints, local area energy planning, and decarbonisation. From this, big win datasets were identified. These are datasets that can facilitate the most use cases. These datasets were network topology, network maps, connection locations, for instance, capacity and limitations, and location and description of constraints. And then Work Package 3, which we most recently completed, we've developed a data sharing assessment tool and the associated documentation and guidance. We trained the tool on datasets we already knew that were open to ensure that the outcomes were correct. Since then, we performed the assessment on datasets we're looking to release in the near future via the Open Data Hub. The learning from this was around the simplification required so that all data custodians can use the tool to classify their own datasets. As before, Work Packages 1, 2 and 3 are completed, leaving Work Packages 4 and 5. Work Package 4, Open Data Hub Development, entails a continuation of the development of the Open Data Hub that will be hosted within the WPD website. The hub will exist so that third parties can obtain WPD data that the project's data sharing assessment has deemed to be safe to share. Third parties will then be able to use this to realise their own use cases and benefit from them. Upon completion of the Data Hub, WPD will also launch a Data Science Challenge, which will ask the data science community to use the Hub to assist with an energy systems problem for a prize. This will drive immediate value from the Hub and validate its existence. More information regarding this opportunity will be released soon. If you wish to be contacted about the Data Science Challenge, please get in touch with me using my email address, which is displayed at the end of this presentation. As the project has a heavy focus on your benefit as industry stakeholders, it continues to look for your views. We're soon to formalise arrangements where you will be able to comment on the look and feel of the planned Open Data Hub. And as before, we would like as many people as possible to register interest and participate in the upcoming Data Science Challenge. Beyond this, WPD now has a dedicated digitalisation team, and you can join our digitalisation stakeholder list by sending your contact details to the email address that's on screen now. Thank you for your time today. I've been Sam Rossi Ashton, WPD's Presumed Open Data Project Manager. I'll be hosting the data breakout room to answer your questions later on, but if you have any further inquiries beyond that, please contact me on my email address, which is on screen now.
Thank you, Sam. Now, there was mention made there of the pod project wanting to engage with stakeholders, and an email address was provided. If you didn't get a chance to note that down, then all the presentations from today are going to be available after the event, and we'll get details of that to you. Okay, so it's question time again now, and this time we'd like to hear about your preferences on style of dissemination. So, so let me start the poll on that. Okay, so hopefully you should be able to see that now. So let's imagine a time where we don't have the current COVID-related constraints on us. What would be your preference? Would it be larger face-to-face events that previous balancing act sessions have been? Perhaps you'd prefer smaller events focused on single projects and making further use of webinars and such like. Okay, I'm just going to allow a little bit more time as you digest thoughts on that. So we've still got responses coming in. Thank you very much indeed. Okay, last few. So going, gone, I think. Okay, so let's have a look then. Okay, so oh, right. Okay. So a split event again, perhaps shading it. Well, definitely shading it is individual project webinars. Now, I know that we do an amount of this, and it's good that that there's continued interest for that. Larger virtual events. Well, that's a bit of a sad face for today, but let's put that down to circumstances. And I guess everyone is craving a little bit more face-to-face. Time there. So thank you folks for that feedback. We do appreciate it. Okay, now we're going to get back to, we're actually now going to go back to Matt and we're going to get him to talk about another aspect of flexibility services. And again, this is focused very much around the domestic setting. So, so Matt.
Hi, I'm Matt Watson from the innovation team at Western Power Distribution, and I'm here today to talk to you about our FutureFlex project. So today I'm going to give you an overview of the project, talk about the progress we've made to date, pull out the key learnings so far, and then discuss the next steps. So what is FutureFlex? Well, it's a network innovation allowance project which is being supported by Everose and Smart Grid Consultancy and is about midway through a 2-year cycle. What it's aiming to look at is sort of next generation DSO flexibility services. So there's an acknowledgement that we are already procuring flexibility services. So for WPD it's via Flexible Power, but these tend to be focused on larger assets, and they haven't deliberately excluded domestic participants, but they equally haven't deliberately designed to account for them and to ease participation. And so that's what FutureFlex is all about. It's looking to develop second generation services with a focus on the domestic scale, looking at kind of how we can make services accessible and widen the potential pool of overall flexibility providers to help drive liquidity and flexibility services for the DNO. One of the key elements of the design of the project is that it was inherently participant-led. So we started with a number of workshops with participants to understand the key limitations around participation, so what were the key barriers, and then sort of created 3 follow-on work streams to help provide some solutions to those barriers. So, as I mentioned, we ran a number of workshops and came up with a series of ideas. And I thought it'd be good to run through those ideas so you got a clear view as to kind of what we've done so far. So the first idea was all around DSO ready homes. So the view here was about trying to understand how we can try and encourage flexibility at times when it is most beneficial to those providers, i.e. moving away from the sort of traditional procurement cycle where we identify our issues and put them out to the market. Actually, there are certain times that are opportune in the sort of customer journey where it's much easier to bring in flexibility services than others. And so DSO Ready Homes is looking at where those processes might be and what can we almost piggyback on to try and enable homes to become DSO ready at minimal cost and effort. And what we've done on that so far is we've created the definition of what a DSO ready home is. We've identified some particular use cases and some potential sort of customer perspectives, and we are currently in the process of mapping some of the mitigations. We then move on to the second strand that we're looking at within the project, which is this Sustain H, which is all about a simpler drop-to service. So again, with what we're doing under Flexible Power, we have a weekly process where people submit availability and we accept or reject that, and there's a relatively complex baseline process. What we're trying to do with Sustain H is really to strip that back. So building on the sort of Sustain product, which is part of the Open Networks standard product set, which is all about kind of further ahead scheduled service. What we've tried to do is take that scheduled service, apply it to smaller participants, and so what we've done there is to try and have real clear, simple baselining approaches where we use some of our modelling assumptions for different low carbon technologies to set what we think a baseline might be for those assets, and then allow people to say what they would drop, how much they would drop by, and effectively just give them a target they're dropping to. And so as long as they hit that target, they would effectively get paid for the difference between that target and our baseline. So a really simple service. We spent quite a long time developing that service, and we have 8 participants who are keen to participate, and a number of those just went operational in November. In terms of our aggregated data work stream, this is kind of a subset of that Sustain H trial, but looking at trying to understand what data requirements we have from domestic participants and trying to understand whether some of the concessions we might need to make to facilitate participation have any material impact on WPD. So, historically we've required minute-by-minute metering, we've required relatively complete metering, and what we're trying to do is try and understand which of those factors are actually important, what is the potential risk that we as WPD might take, and therefore are there any derating factors that should be added into sort of domestic views. And so what we've done on that so far is we've kind of reviewed the initial data sets. We've had a first pass of the initial report trying to develop some of those derating factors, and now we're in the period of trying to collect more data so we can then review these again later in the project. And then finally, the final bit of the FutureFlex project is our pro-low carbon workstream, which was based on feedback that actually a lot of the domestic side of things are relatively green, and actually if we could value carbon in the way we procure services, that would give them a competitive advantage. We discussed this quite heavily with Bayes and Ofgem, and there was a view that actually before we start considering valuing carbon and whether that sits with DNOs or with wider policy, actually a starting block would be to develop a methodology for just assessing the carbon impact of flexibility services. And so that's what the Carbon is trying to do. And effectively where we are with that is we've developed a methodology for the assessment. We are now reviewing that, and we will be sharing that shortly. So there is quite a lot of learning that's been generated in this project across the various work streams, and we're just trying to kind of summarise it into some of the smaller sort of high-level elements. I would point you to, there's a lot of reports and learning that's sort of being updated to the website, so please do have a look at that. So if you want details about exactly how the Sustained H trial works, please do look at that. If you want some of the detailed reports around proto-carbon or aggregated data, please review. But I think the first thing to look at is that it really is quite a lot of appetite to investigate this domestic flexibility services. We had really good attendance at the workshops, really good feedback, and the number of people who are willing to trial the services exceeded our expectations. I think the counter to that, though, is that this is really quite an immature market, and so whilst we've got lots of people who are very keen to trial and push forward, the number of participants has exceeded our expectations, but the number of assets has been on the lower side, and it's quite interesting to see the kind of where we are in the market. I think it is just, this market is emerging, it's still very early, and therefore lots of assets are quite difficult to bring around. I think it's also unsurprising that the way in which we manage data is quite important in these trials. So how we do asset validation when you're starting to look at personal data becomes quite tricky, and I think our work so far on the Sustained H trial has shown just how tricky that can be. And then I think the final bit of learning was that kind of clear view that we got from Bayes around what our role is with carbon impacts and whether we should be valuing. We got quite a strong pushback from Ofgem and Bayes that actually it's probably better done by wider, more accountable policymakers than individual DNO. So what are the next steps for the project? Well, the Sustained H trial will continue running. As I mentioned, there are a number of participants who went live in November, and they will continue to operate over the winter season. And then we will also be looking to bring the additional participants live for the summer season. So effectively in that process is a case of getting participants live and then collating feedback and understanding how useful the service is and how it can be amended and what needs to be done for it to roll out. We also want to understand how effective it is and how it sits in sort of the wider market context. Secondly, we'll then, as we're running the Sustained H trial, we'll be collecting more data from participants, and that will then be used to feed into our aggregated data work stream. So we'll then be able to rerun some of the analysis with enhanced data sets to try and refine some of the findings we've got. We'll then look to finalise and trial the last interventions as part for the DSO Ready Homes work stream, and then along all of this we will look to disseminate the learnings as we do with all innovation projects. So that's the quick summary of the Future Flex project. If you do have any follow-up questions, then please do get in contact. There's also a wealth of documentation on the WPD website.
Okay, folks, well, welcome back. Over the next hour or so, here's some of what we're going to do. We're going to hear about 3 more of WPD's innovation projects. We're going to run our breakout session where you'll get a chance to discuss projects, and then Yango will close the event for us. So let's get started. Next up is further work that WPD is doing on the impact of electric vehicles. So Ricky.
Hi, my name's Ricky Duke, and I am an Innovation and Low Carbon Network Engineer for Western Power Distribution. I'm here to talk to you about Electric Nation Powered Up. So this project is an NIA funded project, and it follows on from the very successful Electric Nation 1 project. So just a few points here on what I'm going to be covering in this presentation. I'm going to give you an overview of the Electric Nation Powered Up project. I'm going to go through some of the progress which we've made to date. I'm going to talk a little bit about recruitment for our end user trial and some interesting facts we got out of that. I'm going to cover some learning so far, and I'm also going to cover the next steps. Also, if you drive a Nissan Leaf, towards the end we'll be giving you details on how you can get involved in our main trial as well. So on to Electric Nation Powered Up. Electric Nation Powered Up kicked off in January of this year, and the project will take 2.5 years to complete. It has a forecasted spend of £2.6 million, 90% of which comes from the Network Innovation Allowance. And the real jewel of this project is we're going to have a 12-month V2G trial with up to 110 Nissan Leaf drivers, and obviously provided by our project delivery partner, CrowdCharge. So Electric Nation Powered Up comes off the back of the highly successful Electric Nation project. In Electric Nation, we had just shy of 700 EV drivers engaged in real-world smart charging, which led to the nearly 2 million hours of data collection. And we got first-hand feedback of what it was like to live with an EV, charge an EV, and also experience smart charging as well. This project follows on from that. It's taking it a step further, and it's exploring vehicle to grid. So not only taking power from the grid, but also enabling your vehicle to push it back onto the grid, and the commercial incentives for doing that. So this project, we're looking to, I said, recruit up to 110 Nissan Leaf drivers and up to 5 energy suppliers, and we really want to understand what the future world will look like. National Grid Future Energy Scenarios predicts up to 15% of homes will have V2G capability in the future. And what we want to understand is, rather than a single stack supplier world, how it will work with multiple different suppliers. So what are we looking to get out of Electric Nation Powered Up? Well, we're looking to see how V2G is going to affect the low voltage network in the future. So we're going to try and recreate the future by onboarding multiple energy suppliers and running multiple different charge and discharge cycles through the network all at the same time. So we're going to report on the impact of the LV network using the end user trial data. We're then going to do some modelling. So we're going to aggregate these all together as if they were on a feeder, and look at how V2G can assist with management of the LV network demand. We're going to examine how bidirectional energy services, based upon the vehicle battery, may impact the LV infrastructure. And we're going to provide recommendations for policy and commercial frameworks on V2G services. So like I said, the project kicked off in January, and since then it's been really busy. So we've obviously completed the design and the setup phase. We have set up all of the customer recruitment systems, and we've actually kicked off recruitment, which is going really well at the moment. We selected the hardware that we're going to use throughout the trial. So we went to a process of analysing all of the current V2G chargers on the market, which there aren't actually that many at the moment. But we've selected the wall-box V2G charger, coupled with one of CrowdCharge's own controllers, and some import and export meters, which are ready to go into the customers' homes. We have already had technical discussions with 3 of our contracted energy suppliers, and one of which we've already presented in an end user proposition to one of our trial groups. And since the recruitment launch, we've received over 400 initial inquiries from Nissan Leaf drivers who want to take part, which is a really promising and exciting start. So we're now well into the recruitment phase, and we've started to draw some really interesting learning from the applications that we're getting into the project. So during this phase, we've seen the number of applications from people that have more than 1 or even more than 2 electric vehicles really significantly increase. Certainly since the Electric Nation 1 project, where only a handful of applications have more than 1 electric vehicle. What we've seen to date on this project is 15% of applications, so that's just over 40 applications so far, have multiple electric vehicles at their properties. And actually a very, very small percentage there, you can see 0.67% of them actually have more than 2 electric vehicles at their properties. So it's really interesting learning that we're starting to pull out of this, that maybe now EVs aren't just second cars for people, but actually whole households are switching over to electric vehicles. So the learning so far in the project, like I said, we've had some interesting learning around the numbers of applicants that have more than one EV at home, and we've also had some interesting insights into our applicants that already have another low carbon technology installed in their home. So you can see there 43% of our applicants have solar PV installed, and 12% of our applicants also have a stationary battery storage device installed, which is really interesting. Obviously, as part of the project, we're accepting those who have solar installed in their homes, but unfortunately not the batteries at this moment in time. That's mainly due to around technical considerations of controlling the battery and controlling the export when the car is exporting also. So as I mentioned on the introduction slide, if you drive a Nissan electric vehicle, so a Nissan Leaf or a Nissan van with bigger than 30 kilowatt hour battery pack, you may be eligible to take part in our 12-month end user trial. So the criteria to get involved is you must live within one of our 4 licence areas. So that's the East or the West Midlands, the South Wales or South West. You must drive a Nissan electric vehicle with a battery capacity of 30 kilowatt hours or more, and you must have that vehicle for the duration of the trial. And you must only have one electric vehicle in your household at the moment. If you are interested in taking part, please do visit the electricnation.org UK website to start your application. You can see the homepage there. If you enter in some simple details, then the crowd charge team will get back to you and hopefully progress your application. In return for taking part, we will install the very latest Wallbox V2G charger in your home, and you'll be compensated for the energy that we will be cycling through that unit, as well as being one of the first people in the country to take part in a really exciting trial like this. So yeah, if you drive a Nissan electric vehicle, please do get in touch. We'd be really happy to hear from you. So next steps on the Electric Nation project. Well, we're going to continue with our customer recruitment. We've now started our pilot site testing. So we've got a handful of chargers in at locations across our regions that we've now started to test the Wallbox charger with. We're then going to be moving forward and completing home installations for our end users. So those participants that qualify, we will be installing the latest Wallbox charger at their home. We're also going to engage more of our energy suppliers. So like I said, we've onboarded 3 energy suppliers at the moment, with the view to getting 2 more on board. And we will be releasing the energy propositions out to the end users shortly. And then midway through next year, we're going to kick off our end user trial, which is going to last 12 months. This is where we're going to gather the really useful data on how it's going to impact the network and the customer behaviour around us as well. So although the COVID-19 situation is still going on, the risk is now lower through obviously local lockdowns and things like this. So we're going to continue the project through. It hasn't held us up too much yet with installations, but obviously we'll be working in line with government guidance and depending on local lockdowns and things like that. So yes, busy times ahead. So thank you for your time and your interest in the Electric Nation project. If you would like to find out more about the project, please do have a look on the innovation pages of the Western Power Distribution website. On there, we'll be posting regular project updates, as well as any reports that we produce and any learnings and findings from the project. Alternatively, you can also go to the electricnation.org website, as well as applications. We'll also be posting regular updates on there and reports just like the WPD website. Finally, if you have any questions about the project, please do feel free to drop me a note to the email address there below, and I will come back to you. So thanks once again for your time and listening.
Thanks, Ricky. Personally, I think that vehicle-to-grid transfers may have a tremendously important impact on our networks over the next 10 years or so. So great to hear about work in that area. Okay, so right, we're at audience participation time again, and this time we'd like to hear about the WPD innovation priority areas that you're most interested in. So we've got the 5 areas that Yango talked about earlier on this morning. So if we start the poll there. Okay, so as I say, what we'd like to hear about is what are you most interested in the priority areas that we've got? Where do your interests lie? So we've heard about transport and data areas today, and communities and customer vulnerability is something that we've recently had a call for ideas on. So watch this space for more of that in the future. If we just allow ourselves a few more seconds just to get feedback from everyone. Okay, so it looks like we're just about there. 1 or 2 more coming in there. Okay, we'll pause there and have a look. Okay, so decarbonisation and net zero, yeah, it's clearly ahead and it is an enormous agenda item for us over the coming period. Perhaps no surprise around transport then. Good to see interest around data. And as I said, I think heat is something that perhaps is going to grow on us over the next few years. Communities and consumer vulnerability, well, it is important, and we have gotten a call out on that. Okay, thank you folks for sharing your views on that. That's great. Okay. So now what we're going to do is that we're going to return back to Ricky, in fact, to hear about one of our larger network innovation competition projects. And that's looking at how we might support the low voltage network in a novel way to facilitate vehicle charging. So, so Ricky, back to you.
Hi, and welcome to this presentation on Western Power Distribution's NIC project DC Share. My name is Ricky Duke. I'm an Innovation Low Carbon Network Engineer, and I will be taking you through this presentation.
Okay, so just a very quick overview of what I'm going to cover in this presentation. First off, I'm going to go through an overview of the DC Share project. I'm going to go through the project aims and objectives. I'm going to cover off the progress that we've made since kicking off in January this year. I'm going to cover off key points of learning that have been generated. And I'm also going to run through the next steps of the project as we start to progress into final design and then the build phase.
So DC Share, what is it? So it's a 3-year project that kicked off in January of 2020 and it's going to finish up in March 2023. It's a £5.6 million network innovation competition project, and we're delivering it together with Ricardo, Turbo Power Systems, Electricity Northwest and VecDOS. So it's quite a big consortium involved in this project. So what is it? Well, with the rise in the uptake of electric vehicles, there's a need for rapid chargers to be placed in dense urban areas such as town centres and things to enable people to charge, get a charge for those who haven't got off-street parking and for those who dive into town to get something. So DC Share is a new and novel way of supplying the capacity to charge the vehicles using rapid chargers. So our conventional way, if we were to go and install some conventional rapid chargers into a dense urban area at the moment, we would have to replace the transformer. We would have to probably do some heavy reinforcement on the 11 kV circuits, all which is very, very costly. The DC Share system, we're going to design, build and trial a meshed DC network on the low voltage system. So we're going to put DC converters into 4 distribution substations, link them together with DC cables, and then we're going to siphon off the latent capacity of these sites and be able to provide that for car charging. So rather than loading it all onto one site, we're going to spread the load across 4 in real time, and that should alleviate those reinforcement issues. So in this project, we're aiming to trial new power electronics and use DC mesh networks in an innovative way. So we're going to link distribution substations together with different load profiles. So we'd like to select 2 substations that have industrial or commercial type load profiles. If you look at the little diagram on the bottom of the page there, you can see they've got a top hat type profile. And residential profiles, so you can see the typical residential profile on the bottom 2 graphs there. And what we want to do is we want to mesh these together with a DC network so they can share the latent capacity within real time. So you can see there on the residential networks, there's latent capacity when there's demand on the commercial profiles. And likewise in the T-time peak for domestics, there's latent capacity on the commercial substations there. So if we can flex that between the 2 substations, we equalise that demand, and therefore that gives us more headroom to be able to supply rapid chargers with a DC supply. So by doing this, by taking a little bit of capacity from each of those substations and feeding it into rapid chargers, it alleviates the need for heavy reinforcement on any individual one point of the network. So if we were going to conventionally install these, we would have to change out the substation, and there would also be significant reinforcement on the 11 kV as well to be able to provide enough capacity to do this. So it's a really new design and a really novel way of gaining capacity from the network. Okay, so progress to date. Well, first off, we undertook quite a lengthy site selection exercise where we analysed all 130 odd local authorities within our 4 licence areas for many different parameters and factors, and we finally settled on Taunton within our southwest licence area as our trial location for the network. We have completed the initial design of the innovative elements of the DC to DC rapid chargers and the grid-tied inverters. We've done extensive modelling of the proposed DC network. We've gained all of our planning permissions for placement of the rapid charging infrastructure. We've had to go through a lengthy design for our communication and control system, which we've now drawn up the specification for this. We've drawn up the use cases of the DC network, and we've also procured the long lead items, namely the silicon carbide that's needed to produce the converters. So this is what the trial network is going to look like down in Taunton. So you can see there we're going to place rapid chargers in Firepool Car Park where there'll be 6, Cannon Street Car Park where we're going to deploy another 6, and the Coal Orchard Car Park where we're going to deploy 3. So these are going to be a mix of 100 kilowatt CCS chargers and 50 kilowatt CHAdeMO chargers. The 4 substations that are going to be supplying the network are St Augustine Street, the Works Substation, Eastgate Gardens and Hammett Street, and these all house the grid-tied inverters which will take the latent AC capacity and convert it into DC. Also in the Coal Orchard substation, you can see there, we're going to put a control point for the control system, and that will look after all of the EV chargers and all of the GTIs and keep everything talking to each other and responding in real time. So we're going to be putting in DC cables, so it'll be a loop in, loop out type of system. So for every GTI there'll be a loop in, there'll be a loop back out. And we're also going to put a new fibre network in as well to ensure there's a really low latency control system to keep everything in check. So that's a quick overview of what the system is actually physically going to look like. So learning that we've generated so far. The main points we've learned already are based around the site selection process. So we undertook a really detailed site selection process to narrow it down to the right local authority. This included analysing current EV charging infrastructure, the number of electric vehicle registrations on the road, getting support from the local authority. And then we had to look at the technical aspects of it, such as finding substations big enough to house the DC converters
and had spare capacity on the network at that point to support the project. What we didn't anticipate is there was a lot more factors involved with this. So we have interacted with all kinds of agencies, from the Environment Agency to the Highways Authority, many different land agents, trying to secure small parcels of land, or trying to get rights to cross to put our cables in. And all of these non-technical issues require careful and detailed analysis. So this is definitely something to factor in if you're going to undertake a large infrastructure project such as this. So the best scenario to conclude the site selections quickly is to only consider substations which are located entirely upon WPD owned land and already have sufficient space to house the new equipment within. So next steps. So we're entering a really exciting phase of the project now. Our final system design report is due the end of this year, and then we're going to start construction of the grid tied inverters and the chargers the beginning of next year. We're going to complete and finalise the trial design to Ofgem by mid-December, as I said. We're going to procure the components for manufacture and the control system. We're hoping to do factory acceptance testing towards the latter part of next year. And then we're hoping to get our shovels in the ground and actually start installing the network the end of next year. And then, of course, we'll kick it off with a 12-month trial. So we will run through the different use cases and we will trial these across the DC network, followed by analysis and reporting. So thank you very much for your time and your interest in the DC Share project. As you can see, it's going to shape up to be a really exciting project. If you want more information on the project or like to be kept up to date with things, please do go onto the innovation pages of the Western Power Distribution website, where we're going to be posting regular updates and sort of trial reports from the project. There's also a DC Share website you can check out, dcshare.org, where we'll be posting more localized updates and again overall project updates and reports. So once again, thanks very much for listening. If you do have any questions, please feel free to drop me an email at the below email address, and thank you for your time.
Thanks, Ricky. Lots of hard work undertaken there in the design phase of that project, and much more to look forward to, I think. So we're going to continue with this theme of vehicle charging now, and how supporting its growth is crucial. This time, we're going to take a look at the challenges of supporting in-journey charging. So Neil, over to you.
Hi everyone, I'm Neil Murdoch, Engineering Manager at GHD, and today I'm going to talk to you about WPD's NIA project, Take Charge. Here is an overview of what we're going to discuss in today's presentation. Firstly, I'll give an overview of Take Charge. I'll then discuss the problem that Take Charge is trying to solve. I'll then talk about the solution that Take Charge is going to provide, and I'll discuss the progress that we've made to date on the project and some of the key learning that's been generated. Then I'll talk a bit about what we're going to do next on the project. Here is an overview of Take Charge. The project started in April 2020, and we've been currently working in the design phase, and we're shortly to be moving into the build phase. The project's due to finish in December 2021. The contract value for the project is just over 1.3 million, and we're working with GHD, Brush, Moto, and Ecotricity. As I mentioned, we're currently in the development of the design for the connection solution. So what is the problem that Take Charge is looking to solve? Well, it's clear that the deployment of rapid EV charging is becoming increasingly important as customers want to have less time charging their vehicles and more time on the road. Motorway service areas were identified as a key location for the deployment of rapid charging facilities. However, with the increase in rapid charging infrastructure comes the need to provide additional power supply capacity. Unfortunately, a lot of these motorway service areas are supplied at low voltage, and there's not a lot of capacity on the network at that point. Studies have shown that to deploy EV charging across MSAs, is likely to require a supply of up to around 20 MVA or even more for some of the larger MSAs. So what is our solution to make sure that we can get the power supply capacity required for all these rapid charging facilities across motorway service areas? Well, what Take Charge is looking to do is specify, design, test and trial a brand new standardised package solution that's able to be quickly deployed to site and provide a far more cost-effective solution than traditional methods. We've called this the Compact Connection Solution, and our plan is to be designed and built in conjunction with Brush, who are a leading manufacturer in switchgear and transformers. We're also looking to install this at a Moto MSA within our own license area. It will be connected to our 33 kV network, and we'll be able to provide significant capacity for both existing EV infrastructure and new infrastructure. As I said before, this is really going to be a plug-and-play solution that's going to be far more efficient than our existing solutions. This slide provides an overview of the work packages for Take Charge. The first package looks at the system capacity optimization. That includes looking at which site we've chosen for the trials and also looking to see how much capacity is required at that trial site. The second work package is all around the development of the solution, and we're currently working on the functional specification and the detailed design. The third work package is all around building the solution and installing it at the trial site. And finally, the last work package is the trial and evaluation of the new compact connection solution. So the next few slides, I'll talk about what we've done so far on Take Charge. As I mentioned earlier, the first key package for Take Charge was to select a site that we would use for the trials of the new compact connection solution. We achieved this by developing a site selection methodology. The methodology looked at 6 key areas: the proximity to the point of connection, the access to the MSA, the network configuration, the point of connection configuration, the space around the MSA, and the visitor usage. Using these factors, we were able to look at all the Moto sites within our license area and pick the most suitable one for the trials. After evaluating 13 sites in total, we chose Exeter MSA as the most suitable site for the trials of the compact connection solution. You can see a photo of Exeter MSA and also an overall site layout on this slide. The next part of Work Package 1 looked at calculating the capacity required for the new compact connection solution. Now that we had selected Exeter MSA as the trial site, we could start to look at things like the road traffic behaviour, customer behaviour, charging demand, the local infrastructure to determine how much capacity would be required at Exeter MSA. Taking all these factors into consideration, our engineers provided a forecast of where we would see the EV charging demand up to 2050. Our calculations showed that the EV charging demand would likely reach around 18 megawatts in 2050. The 12 megawatts and 24 megawatts shown in the graph are basically the split into the two distinct capacity groups. The second work package looks at developing and designing the compact connection solution. We've been working with our project partner Brush to develop a functional specification for the compact connection solution. This has now been finalised and we're taking this forward now into the detailed design stage. It's important to note that we've used learning from SSE's MASK project within our functional specification. In addition, we're looking to focus the design around reducing the footprint, interfaces, maintenance and commissioning of the substation. Finally, we're looking to have a modular design that will allow for future upgrades with minimal disruption in cost. Through the work that we've completed on the project to date, we've generated some key learning. This learning has been captured in the project reports that we've published, and you can find these online on the WPD Innovation website. I thought it was worth highlighting 3 key areas of learning on this slide today. The first relates to the EV charging patterns at MSAs. Through work with Ecotricity and Moto, we're able to establish that EV charging patterns at MSAs were actually very similar to standard public charging patterns. This is really useful and helped us determine the capacity for the compact connection solution at Exeter. The second point focuses more on the functional specification for the compact connection solution. When we were looking at this, it was clear that the way we were going to produce the compact connection solution would have to be focused around the ratings of standard DNO infrastructure, and as such, we've had to incorporate this within the functional specification. Finally, we looked at customer behaviour. Understanding how customers would behave and when they would charge their vehicles was important to understand how those would affect the charging patterns at MSAs. Using data from Moto, we were able to predict when customers might be likely to charge and how many customers might be charging at any one time. However, it should be noted that these behaviours could change in the future depending on how charging technology changes and how EV technology changes as well. So just moving on to our final slide now, what will we do next on Take Charge? Well, we've already completed Work Package 1 and we're currently delivering Work Package 2, and we're hoping to finalise the detailed design of the compact connection solution by the end of this year. When the design's complete, we'll move into Work Package 3, where we'll begin the build of the compact connection solution and start the site works ready for the installation. We're currently on track, and we're hoping that by the end of next year, we'll be in a position to complete our trials and evaluate the compact connection solution. That completes today's presentation on Take Charge. If you'd like to find out more information, feel free to go onto the Innovation website and find out more details there. Thanks very much for your time.
Thank you, Neil. There's another example there of an innovation project that's seeking to iron out the feasibility and the development challenges of something that we expect to do much more of in the future. So thanks. So that brings us to our breakout sessions. And now, if the wonder of Zoom does its job, in a moment or two, you're all going to be magically moved to your breakout rooms. And these are based on the preferences that you gave us during registration, so on registration for this event. So we hope that these smaller sessions will provide the opportunity to discuss some of what you've seen today. And then at the end of this breakout session, you should all get seamlessly transported back again to this main session. So I hope very much to see you on the other side of this breakout. Okay, folks, well, welcome back to our main session. I hope you found the breakout session useful, interesting, and worthwhile. So we're now near to completing our program for the day, and we've got two further poll questions for you. So please do stick with us as we go through those. Okay, so the first one that we've got is really just following on from that breakout session. What did you think of it? Okay, so let me just start that poll question for us. So our fifth poll question, there we go, that's launched that away. So how satisfied were you with that? Did it work for you? Did it not? How did we manage to do on technology? So I can see some responses coming in there. Thank you very much indeed. Oh, that's interesting. We seem to have stopped that. So let me just share the results on that. Well, look, firstly, can I say thank you very much indeed for you know, the proportion that found that satisfying or very satisfying. That's great. As ever, folks, if you do have some further feedback at the end of this, we will get the slides out and there will be the email addresses on that. So if you've got some further views, please do share that with us. We would appreciate it. Okay, so moving on then from that question about the feedback session, what we'd like to do is just ask you now, how do you feel about the day overall? Okay, so let's just launch that and get some feedback there. So that's that's launching now. So overall, how would you rate today's showcase event? Lovely, thank you for those votes. We really appreciate it. We'll see if we can just hold on there and get just as many of you with us to give us some feedback there. Okay, I think we're just about there. So let me share the results there. Again, thank you, folks. We appreciate the feedback. And as I did say, you know, if there are any other pointers that you'd like to push in our direction, please do let us know about that. Okay. So thank you all for participating in today's polls. They've certainly helped inform us. What I'm going to do now is hand over to Yango, who's going to draw together things from today and close the overall event. So Yango, over to you.
Thank you, Chris. You've done a great job presenting our event today. So on behalf of the whole team, thank you for all of your hard work. And thanks to all of the innovation engineers as well for sharing the learning on their projects through their presentations and hosting the breakout sessions. And thanks to all of you for joining us today. We've heard together about our innovation strategy and how that's implemented by the engineers in the innovation team through the delivery of their projects. Through our portfolio of projects, we discussed how we aim to continue transforming our network. And as part of that, we want to be working with the best people in the industry. So again, if you have a great idea that can help us facilitate the low carbon transition and benefit our network and our customers, please do get in touch. We have also had some great discussions with you in our workshops, so thank you for all of your input. We will now take all of the feedback that you gave us today and use it to shape our plans and future projects, and also to make our following events even better for you. So thank you all again for joining us today, and we hope to hear from you soon.